Good day, everyone. I am Miss Jenilyn M. Pones, and today we're going to talk about the union and intersection of events. First off, I will need you to remember the following. We're not gonna need them now, but you're going to need them in your future lessons, especially in probability. So first, we have experiment. So it is an activity which could be repeated over and over, which have well-defined results. So first, we have an example, and I'm going to use the very common ones. So first is the rolling of a die. So of course, you can roll a die over and over, and in the event of doing so, you can get results. And the experiment of tossing a coin. Then we have outcomes. So these are the results of an experiment. Of course, if you're going to perform an experiment, then you also have results. So first, in an experiment of rolling a die, you could get one number out of the 6 faces of the die. And if you toss a coin once, you could either get a head or a tail. Then, we also have the sample space. It is the set of all outcomes in an experiment. For example, in experiment of rolling a die once, this is the sample space. It's simply listing down all the possible outcomes and then enclose them with curly brackets and separate them with commas. And then, in the experiment of tossing a coin, the outcomes, the head and the tail, enclose them with a curly bracket and separate them with a comma. Then, the event is a subset of the sample space. So, in an experiment of rolling a die, we could get an event of getting a 5 or a 3 or a 1, whatever it may be. And then, in experiment of tossing a coin, you could get an event of getting a head. As I've said, we're going to be talking about the union and intersection of sets today. That's why you're going to need your knowledge on the notion of sets and the operation on sets. So first, let's talk about the union of events. So the union of events, it consists of all outcomes in the sample space, say S, that are contained in event A or in event B or both. So it's usually denoted like that: A union of B or A or B. So the union of events is like this. So one or the other or both events may occur. Let's go over to some examples. So first, we have set A, set B, and the union of set A and B is like this. So you notice that set A and set B has both 1. Remember that an element shouldn't be repeated. That's why we only have the union of A and B as 1, 2, and 3. Then we have another set, then set B, and the union of set A and B goes like this. Then another example, we have set 1, A, B, and C, and set 2 containing the letters A, C, D, and E. So what about the union of set 1 and 2? It's simply A, B, C, D, E. Okay, what's very interesting in the union of events is that you simply need to copy all the elements from both sets, but the elements shouldn't be repeated. We also have the intersection of events. So the intersection of two events A and B is the event consisting of all outcomes in the sample space S that are contained in both event A and event B. Meaning it should be in event A and it should also be in event B. So it is read as and, since both events should occur. Then the example of the intersection of events. So first is set A, which has the elements 1 and 2. Set B, which has the elements 1, 2, and 3. So the intersection of sets A and B is simply 1 and 2. You notice that 1 is in event A, it's also in event B. 2 is also in event A as well as event B. Then, another example, we have event A, which has 1 and 2 as its elements. Event B, which has the elements 1, 3, 4, and 5. So what do you think will be the intersection of these two sets? Okay, so it's 1. Then another example, we have set 1. It contains the letters A, B, and C. And set 2, the letters A, C, D, and E. So the union of sets 1 and 2 goes like this, A and C. Simply put, the intersection of two events is what's common in both sets. Both sets. Let's compare the union and intersection of events. So first, we have these sets. Set A, which contains the letters A to I, and then set B, which contains all the vowels in the English alphabet. So first, the union. As I've said, the union of these two sets is simply listing down all the elements in A and all the elements in B. But there's a trick to that. As I've said, these elements shouldn't be repeated. Now, what about the union of these two? You notice that because I wrote set A as the letters A to I and set B as the vowels of the English alphabet, you notice that the union of these two sets is simply set A, but it doesn't matter. So what about the intersection of these two events? So it looks just like set B, because both A and B contains all the vowel letters. Next example is this. So let's say that J likes the following colors: red, blue, gray, black, and white. Then person R also likes blue, black, gray, and maroon. What is the union of person J and person R's favorite colors? So we have red, blue, black, gray, white, and maroon. And the intersection of their favorite colors, meaning both person J and both person R like blue, black, and gray. It did seem forever, right? But thank you for watching and have a good day ahead. See you on our next topic.